When you're in the lab, remember to always wear your safety goggles and gloves. Start off by pouring the hydrochloric acid into a beaker.
Using the volumetric pipette, measure 10 milliliters of the acid. When suctioning up the acid, make sure to fill above the 10 milliliter mark so as to be able to slowly pour out excess acid by slowly moving your thumb until the bottom of the meniscus is level with the 10 milliliter mark. And then transfer the acid into a 125 milliliter Erlenmeyer flask. The meniscus is the curve in the upper surface of a liquid caused by surface tension. Make sure that you are viewing the meniscus at the proper angle so that the marks of the graduated cylinder are aligned. When the marks are not aligned, a phenomenon known as parallax, it is more difficult to discern an exact measurement.
After you have poured the acid into the flask, pour 2 drops of phenolphthalein into the flask as well. Next, you need to clean your burette. Pour about 5 milliliters of water into the burette and rinse. Then pour about 5 milliliters of sodium hydroxide into the burette and rinse. Use a spin motion to ensure that all sides are covered with the basic solution. After cleaning the burette, secure it into the burette clamp.
Next, use a plastic funnel to pour the sodium hydroxide into the burette. Fill the burette to a little over the 0 mark. Let a little of the solution out and record your starting point. In this trial, the starting point is 0.00 milliliters. Place the flask of hydrochloric acid under the burette. Let out the sodium hydroxide in varying increments until the solution turns a light pink. As you're doing this, make sure to swirl the flask. This chemical formula explains the process that is occurring inside the flask. As more sodium hydroxide is added to the hydrochloric acid, the solution gradually becomes neutralized, producing water and salt.
At first, you will notice that the sodium hydroxide dissolves quickly because there are a lot of molecules available for bonding. Once the solution has been neutralized, the light pink color remains. This is what your end result should look like.
Make sure to record the N value. Subtract the starting point from the end point to find the net volume of the sodium hydroxide added. The end point for this trial is 22.20 milliliters. Since the starting point was 0, the net volume of the sodium hydroxide added in this trial is 22.20 milliliters.